Okay, I got a request to do Chileo Island in Chile, in South America, and that's this island here. Now, that's a great suggestion because it is full of amazing features. First thing that pops out to me are these ravines here. And the way they curve and expand, they look a lot like something water would make. Water being a fluid easily expands and coalesces, while ice is something that has a hard time doing that. So even though this is so far south that almost everyone would consider all of this landscape and even the landscape above it to be all carved by ice, when we actually take a deep look at all of these landscapes and are able to figure out a lot of features, we will find that it's actually all water. So they were close, just the wrong state. Now, there's a huge difference between water and ice. And first of all, with ice, it responds to rigid body dynamics. And with fluids, like water, it responds to fluid body dynamics. So the physics of erosion between ice and water is completely different. It's not even the same topic, right? They have their own topics and their own set of dynamics. So with a water, with a fluid, it's going to be really easy to carve these features. It's going to be really easy to dig out troughs and undercut rock because it's got an undulating force, so it's going to want to go up and go down, and it likes to dig when it undulates. And water also has a coalescing force, so it wants to dig, it wants to coalesce and form a tight rut. So they say only glaciers can make U-shaped valleys. Well, if you think about what the opposite of that would be, which is, okay, a glacier can never make a U-shaped or V-shaped valley. Well, go to Google Earth and see if there's V-shaped valleys all over everywhere. Alaska, Russia, all over the place. So even though it says only a U-shaped, there's a lot of V-shapes, and ice can't dig underneath this. Okay. Um, I guess I'll just talk about some more U-shaped. All this is so steep. And the steeper something is, the more of a coalescing dynamic, right? So that would be fluid dynamics, right? So if only ice can make a U-shaped valley, this area shouldn't be full of straight lined ravines. And the reason why a glacier would make a U-shaped valley is because it spreads out its weight more and doesn't focus as much. But imagine you've got an ice sheet covering this entire area. It's not going to dig out all of these tight and narrow paths. It's going to erode more like a blanket. Okay, let's go back to our special island of the day. And we can see that it's separated on both sides by a channel. Here we kind of have a smaller channel and then an expanding shape here. And here we have the same thing where it expands. And actually what's interesting is this actually connects perfectly with this marine terrace. Right? So how do marine terraces form? Well, how can you erode something very catastrophically thousands of feet deep? Well, it needs to be heavier than water, and that's boulders and heavy debris. So there's by finding all of these massive marine canyons that continue for hundreds of miles, that's evidence of catastrophe where water is able to move heavy boulders. And the reason why it has to be catastrophe is because you need inertia. Erosion's all about physics, and that's why I like it so much. Because there's things like inertia and the difference between rigid body and fluid dynamics. Now, this here, you can see water flowed this way and then it streamlined around it here. Same thing on this side. Streamlined here. And all of these land masses, these are all what remained. So you see how this looks just like a river, the way it expands and it curves. This, and then here we have an expansion bar. So imagine this, imagine the water drained off of this and now it was the desert. You'd call that a mesa. Okay, so this whole landscape would be a landscape of desert mesas if there wasn't the ocean here anymore, particularly this area. Look at this. Imagine there was no ocean and it was the desert. And what's underwater is probably, you know, a few hundred feet deep and kind of flat bottomed. Then that would look just like a mesa, which we find in the desert. Now, let's look at, I guess when we zoom in, it kind of gets bad here, but this is a good streamlined path indicating a water current. You know, you look at the hydrodynamics and fluid dynamics are pretty close, but you look at something like a bike racer's helmet in a wind tunnel, it's going to do something like this, where the airstream flows towards the bike racer's helmet and then flows around it. Okay, this one's a cool one because you get two ravines where it kind of splits off here. But this is all from water flowing across, and it cannot be from ice because ice doesn't focus its power into such deep ruts. I'll talk about these ruts later on. But I want to show you, here's another good one. So now we get the other direction, where the bike racer is facing towards us now this way. And the wind flows off, the airstream flows around his helmet. Oh, we can't quite see it. I'm sure it's got something good on it. Ooh, is that mesas? Terraces? Anyways, let's go. Okay, now we're in Vancouver Island. This is another island. Whoops. This is another island that's also streamlined or cut around. So let's just compare these two islands. We've got a big channel that came through here, separated this little landmass. And you've got marine canyons all along here. Now we go to Vancouver Island. This also is completely separated from the mainland by a little channel. But then it comes around Puget Sound, underwater mesas, right? Which are just, you know, remnants of the land that got streamlined from a water current. And then you come down here, you got a lot of scouring. And then it leads into some amazing marine canyons that go for hundreds of miles offshore. And they even have terraces, right? So this is 1 terrace, 2, 3, 4, and 3 cliffs. 1, 2, 3 cliffs. And you can keep going. Let's get a point here. Let's do, and we're just going to do a straight line. 580 miles. And then you look over here and you see some big old channels. 26 easily. And where'd they come from? Flowed right through there. This is a streamlined feature, kind of like the one we saw with 2 ravines. Comes around. Streamlined features all over the place. Cataracts, 3 fingers of a cataract. Okay, now you really want to see some streamlined features? Prepare yourself. This right here is a streamlined feature. This as well here comes in here. I'll show you guys in more detail on a topographical map in another video. I gotta dedicate a video to that because these landscapes are so rich in everything from insane high-speed drumlins, right? You find a nice straight feature like that, that's from a high-speed water current, not from a glacier. All of these lakes are scours. And then we find some nice ripples, and these are not eskers. So they talk about all the features, but they're just not quite hitting the mark on them. 99% of a mile. I'd call that a big ripple. And it's right next to not just this streamlined feature, but this streamlined feature here, which indicates a water current coming the way it's streamlined, right? Think about the airstream. Went whew. So the water current came through here. Now, what do we know about ripples? They form perpendicular to the water current. Oh, those must be ripples. And you can find indentations and ripple formations like this on the beach all over the place. So this is all fitting in perfect. But let's get one more feature. That feature would be drumlins, which are the parallel path of the water current. And that's what we find here, right? This is parallel path. Those are kind of big ones, but these here, these are also parallel with the path. These actually are kind of thinner like accretion ridges. Yeah, I wouldn't call these drumlins. I'd call those accretion ridges, and I'll be able to explain. Oh yeah, look at the way this turns. So this is definitely an accretion ridge formation. So the difference between an accretion ridge and a drumlin is an accretion ridge is more like a lake shoreline, and it's more like a river river deposit. So imagine this river was flowing super fast. It might just leave a little line of built up sediment. That's what this is. So we don't actually see any here. You can find them all over, you know, the Mississippi or, you know, the Amazon. But these fit in directly with the rivers. So this is saying that this river here, it was once depositing from its centripetal force, not just all the way over here, but all the way over here. And all the way around this bank. This was the path of the river. These were ruts made by the current that are now lakes. They're looking a little salty. Oh no. Uh-oh. It's not looking good for the glacier, guys. We've got a lot of salt. Okay. Okay, let's keep going. More parallel path features. Drumlins. Oh, there we go. Now we get our drumlins. So let's see if these drumlins are perpendicular to our ripples. Pretty close. Pretty close to perpendicular. Or here, now we can see it. Because these drumlins are so much thinner and smaller and on a different scale than the ripples, these likely formed later. And that's why the angles aren't quite perfectly matching, but in the general sense, yeah, all of these erosional features are all lining up. Okay, we got to go back to our spot now in Chile, now that we've learned all of that. And we can see how this was once a massive river. And all of this was streamlined. We get a little series of plunge pools. Bing, bing, bing. And then this is a nice plunge pool here. Right, all of these are undercut. So how is a glacier going to undercut and then make a tight little narrow path? This is all water. Okay, let's go. Oh wait, what I see? Nice expansion bar. Had to note that. Nice expansion bar here too, fits in nicely with these ruts. So we get an expansion bar fitting seamlessly with these ruts. How can we explain these ruts? Probably glaciers, right? Not so fast. Let me take you all the way to the big continent they call Africa. Check this out. Zoom all the way in, you might just find some terracing. Zoom out, streamlined shapes, just like what we were seeing. All of these ravines are indicating that they're directional. All right, we can all see the direction. You don't have to take a PhD to understand the current direction of this. And the reason why I brought this up is because this is the same rutting. This right here, look at this. This is the exact same rutting. Parallel ruts, tight, focused, right? So did a glacier come through Africa and scratch it up? No. Something else went through Africa, left behind a 28-mile wide river channel. Let's just do the full thing. I love to just go like this. And then see how this is a streamlined feature. This whole thing. Slightly streamlined, you can tell. This location I love, not just because you get this streamlined feature, which happens to be 6.6 miles wide, but you get a perfect intersection with ripples. Drumlin, ripple, excuse me. Perfect intersection between drumlins and ripples. And what happens when you get a perfect intersection? You might just find the most widespread geologic mystery in the entire world. Mounds. That is one way mounds can form from the intersection of ripples and drumlins. Right, these are all mounds. Mound formations. But go past the massive streamlined feature, we find parallel ruts. These are all parallel, indicating sheet water flow. You know the drill. Drumlins, indicating sheet water flow. Scarp edges with tails, right? That's how we figured out how the Carolina Bays were formed, by finding ones with scarp edges and tails. We zoom in, we find everything we need. Let's just keep going, parallel, rut. So then when people say, oh, we're all these, all these drumlins and massive ripples are all blown by the wind. So did the wind also carve parallel canyons in solid bedrock, solid lava rock? I don't think they would agree to that. The formations are all there. This kind of looks cool here. And then I love this spot here. Gotta love these ripples. You gotta know the wavelength. Let's get a good one. Good set. Oh, this right here is a nice set. From beginning of wave, right there, 1.4 I'm calling it. I'd say not bad. Now, the whole theory of wind-blown ripples kind of falls apart when they're in a lake, right? Now, this is still Africa, but in the most lush regions of the world, you can find massive ripples. And then, of course, you already know about this spot. It's too crazy to ignore. Drumlins, blah, blah, blah. Okay, now we're back. So now, let's go to this spot. Now that we've seen Africa, what do we think about this spot? We got a nice curve. Look at this curve. It's my only sound effect is a lousy whistle, but I'm trying to emphasize how sick this is. Look how pitted this is. Oh man, look at the erosion, you guys. But so all of these canyons are parallel. And they're filled with scours and ruts, right? Because water focuses its energy. Oh my gosh, look at these accretion ridges, and it's all salty up here. So this being a nice badass salt scablands, right? I haven't tasted it, but it looks like salt to me. Salt likes to do that. It could be a light sand. Not sure, but it's pretty close to the ocean. Let's say what I really want to find is something where you can find little polka dot lakes. That's a good indication. And also if someone's mining the salt, they've got little squares up. Those are the best ways to tell if it's salty. But anyways, this could be an indication that the ocean current washed over here. Nice streamlined feature here. Zoom in here. This gives us a good indication of a current direction, right? You can see it went through here. Nice accretion ridges, very pronounced. Look at this. This is just so rutted up and scarred. So if you were to run a program of physics, a model where you had two things, one, an ice sheet 2 miles thick, which sits stagnant, or a water, or imagine the ocean hundreds of feet above this washing around on it. Which is going to create more focused ruts that curve in tight paths? It's going to be the water. That's why it looks so much like this spot in Africa, because if this spot curved a little bit more, I guess it kind of curves here. But here, here it starts turning. We go straight into some streamlined ripples. These ruts are somewhat parallel as well. These ones here. So these are the same things. This is the same type of things we see in South America. And then how do these coves form? Well, the ocean currents streamline or smooth out the coastline, right? That's a fact they'll tell you. The ocean current straightens the coast. That's what they say. So then how do you get a cove which is not a straight coast but is an inlet? Well, that comes from a current, an offshore current that came through here and dug it out. I've got some locations I can show you near Fiji that would make you believe that. But for now, you're just going to have to take my word for it. What the heck? Okay, let me go back here. It's a nice streamlined mount. this is a nice feature here. Let's see, is it U-shaped or V-shaped? We got to know. I'm calling that a V-shape. It's not a U-shape, or not a dramatic one at least. Let's see if we can find some more V-shapes. Oh, this has got to be a good one. Yeah. It's not a wide U. It's a tight V. Straight and steep. Very steep and very straight. So yeah, this wasn't carved out by a glacier, nor were these. Even though the other one was straight and these are all curvy, but all of this glacier erosion, or not glacier, water erosion. And let's look at, see how this marine terrace pops up out of nowhere? Kind of fizzles out here in a deposit, it looks like. But it actually connects to this here, this double ravine, which is even streamlined. But at one point, the current flowed. Imagine a bunch of debris coming through here, down this way, and underwater mud flows and debris flows. So after you have a debris flow, what follows the debris flow is a mud flow that's really heavy and dense. And that's what keeps the inertia going, and it actually pushes the front forwards. I've got a full video on that I explain in more detail. Should check that out. I'm just about done with this video. Okay, this is cool. So a lot of people like to talk about barbed tributaries for some reason, because they think it tells you where the current's direction, but they're actually 180 degrees off when they talk about how smart they are, that they know about barbed tributaries. Because this would be an example of a barbed tributary if you didn't first realize that it's a streamlined feature and that the water current was going this way around it. But because the tributary comes in like this, they're thinking that that is an indication that the water current flowed this way. But that would have no effect if this wasn't completely underwater and this water current wasn't acting upon the tributaries. So when you go to the deepest canyon in North America, that's a feature that is quite interesting. It's the same streamlined feature as this. I'm just going to go there now and show you. Since I mentioned it, it's not too far when you take Google Earth. So these here, streamlined. This here, streamlined. This here, streamlined, right? Just like an Airstream, just like a bike helmet. These are 3 streamlined features. And they say, oh, this is evidence that, the Snake River actually flowed back this way. Like it flowed this way, and it potentially could have had some effect on this insane feature, right? But this is actually an indication of the current flowing the same way as the Snake River does now, because of the understanding how something's streamlined. So now here's what I'm confused about. They're saying that this is evidence, or imagine this right here, evidence of it flowing, of the central stream, the main stream flowing to the south. If this is a tributary way over here, this is a tributary way over here, this is a tributary way over here, how is the main stream going to affect the tributary? It can't affect the tributary unless they're all underwater. And they don't even think like that. So, yeah, that's just kind of, anytime someone talks about a barbed tributary and they think they know something, just say, listen, Might be streamlined the other direction. So let them know for me, please. Okay, so we talked about the current ruts in Africa, the current ruts in South America. These aren't current ruts. I think they just might be current ruts way up high. Some harder to see than others, but you can tell it's from the kind of the current coming through here. It's all scratched up. Okay, that's all for this video. Thank you very much for watching, and I appreciate it. It's a nice valley here. I like this. Look at the bank on this thing. It's got little accretion ridges on it. All right, thanks for watching. I appreciate it, and have a great evening or whatever time of day it is. And hopefully I'll see you again in the next video. Goodbye.